All right, so we're going to discuss the product and the quotient rules. The product rule. When two things, two functions specifically, are being multiplied, in order to take the derivative, we can't take the derivative of each piece of the product separately like we could with the sum rule and the difference rule. So we need to learn this new rule in order to apply the derivative to when two functions are being multiplied. So in pink, it's stating that if you have a function f times a function g, and you want to take the derivative, you need to remember that it is not equal to each function's derivative multiplied. It's not the case. So for example, if we let f of x be x and g of x be x squared, then the power rule gives us that the derivative of x is 1 and the derivative of g is 2x. And if we multiply those, we get 2x. But the actual derivative of our function when multiplying x times x squared, if we add those exponents, x times x squared is x cubed, and also using the power rule, we know the derivative of x cubed is 3x squared. 2x and 3x squared are not the same, therefore showing you or disproving the idea that we can take the derivative of each piece of a product and the multiplication of those derivatives would be the same, and it is not. So what do we have to do? We have to follow this rule, which looks a lot more confusing than what it really is. So I like to write it a little differently, and the way that I write these derivative rules is so that I can actually remember them. So instead of all this f of g and all that garbage, I like to say that I am taking the derivative of a product of functions where f of x is the first function and s of x is the second function. Helps me remember the order, first and second. So when taking the derivative, you are going to always pair the derivative of one function multiplied by the original of the other, plus, and then you switch the derivative of the one you haven't taken yet and multiply that by the original other function. So the order doesn't matter because multiplication and addition are both commutative, meaning the order in which we multiply and add is not important. So really this rule is easy to remember because you just have to remember that a derivative of one function is always being multiplied by the original of the other function. Let's take a look at this example and let's try. So in this example, we have a function x and we have a function e to the x. Until you get comfortable, you may want to write out that the first function is x and the second function is e to the x and find their derivatives. And as this gets more and more complicated, where we're working with functions that have much more complicated derivatives, this is a really good way to organize yourself before applying the product rule. So the derivative of x is just its coefficient 1, and the derivative of e to the x, which is my favorite, is just e to the x. Now the rule, recall, states that when you are multiplying two functions and taking the derivative, you pair up a derivative of one with the original of the other, plus, and then you switch. So my derivative of this function is going to be big F prime of x, which is 1, times the original second function, e to the x, plus the derivative of the second function, e to the x, times the original of the first, x. So if I write this a little neater, my derivative is e to the x plus x e to the x. And I can factor out the e to the x and make it e to the x times 1 plus x, which if I was trying to solve this may make my life a little easier. So if it's unnecessary to factor it, you can keep it in this separated form. Next example. So again, I'm going to identify my first function, which is x to the 4th power, and my second function as 5 raised to the x power. I'm going to find their individual derivatives. So this x to the 4th power requires the power rule, so I'm going to bring that 4 down in front, come back up and subtract 1 on the exponent. This function over here is exponential, and it's going to be ln of 5 times 5 to the x power. Now I'm going to use my product rule and create the derivative of the original function, and that is going to be the derivative of the first times the second original function plus the derivative of the second times the original first function. And although this isn't pretty to look at, it is what it is, and this is the derivative of this product. Now the quotient rule is a bit more complicated. It's when we are dividing two functions. And again, the quotient rule, let me write this out because I actually don't have it written. So the quotient rule, you have to recall that this is very similar, where if we are dividing a function divided by a function and trying to take the derivative, it is not equal to the derivative of the top divided by the derivative of the bottom. So that is not the case either. Again, that only get to separate and take individual derivatives and put them together if it's addition or subtraction. So we need to follow this crazy looking rule. Now, again, it's in F and G's, and for me, I particularly don't like using F and G's. I like to use more phonetic way of writing the rule so that I can remember it easier. So instead, I use top and bottom. So if I wanted to take the derivative of a quotient where there's a top function and a bottom function, I need to remember that the derivative of the top comes first, paired with the original bottom, minus the derivative of the bottom times the original top, all over the bottom function squared. Now, it's important to remember which derivative comes first in this rule because it's no longer addition in the numerator, it is subtraction. And as we know, subtraction is not commutative. So we do need to remember that the derivative at the top has to occur first. Let's try some examples. So our first example is this function y. Now, this function y has multiple terms in the top function and multiple terms in the bottom function. Again, I highly recommend as you're first learning this to identify your top function and find its derivative before trying to do the whole formula. Also, identify the bottom and find its derivative before trying to place the whole formula. This will save you some serious anguish when we have very complicated and multiple rules being used. So this top function has many terms, but they're separated by addition and subtraction. So we can take the derivative of each one of those terms separately. So I bring the 2 down in front, subtract 1. I take the derivative of x, which is just the coefficient, and the derivative of a constant is always 0. The derivative of the bottom, again, I bring the 3 down in front and subtract 1 on the exponent, and the derivative of the constant is just 0. So now using my quotient rule where I have a top function over a bottom function, and I'd like to take the derivative of that, I need to remember that the derivative of the top comes first in this numerator because there is a subtraction, so it matters. So I am going to take the derivative of y by doing the derivative of the top first, which is 2x plus 1, times the original bottom, x cubed plus 6, minus the derivative of the bottom, 3x squared, times the original top, x squared, plus x minus 2, all over the original bottom squared. Now, when it comes to the quotient rule, for purposes of sanity, I am not requiring you to simplify the quotient rule. You can leave it as ugly as it is. Now, in certain cases in the future, you may want to do some simplifications, but I only require that you fix negative exponents. So if there's anything that has a negative exponent, you're going to want to make that positive. Remember to do that. If it's in the numerator, you bring the term down to the denominator and vice versa. Let's try this example with some exponential functions. So again, as I'm learning this rule for the first time, I am going to identify the top function and the bottom function. And then I'm going to take my derivatives. Derivative of the exponential is the exponential. Derivative of a constant 1 is 0, and the derivative of an exponential is an exponential. Easy peasy on that one. Okay, so now let's put it all together into the quotient rule. The derivative of the top comes first, times the original bottom, minus the derivative of the bottom times the original top, all over the bottom squared. Now, with all these exponential functions, this actually will reduce to something really pretty if we wanted to do the algebra out. And in some cases, you might actually find that that is very useful. But I am not requiring any such simplifications except for negative exponents, because negative exponents aren't very applicable. And here is a table of formulas that we learned today, where we discussed that the derivative of constant function is 0. The derivative of a power rule is to bring the power down in front and multiply, and then come back up and subtract 1. The derivative of the exponential function is the exponential function. And we can separate the derivative amongst addition and subtraction, but not against multiplication and division. We have rules for that.